Welcome, it's Mr. Ordinary here, and we're going to learn how to use a scale diagram. And I've got a scale diagram right here. It says that the scale is 1 centimeter to 20 meters. And when we write a scale on a diagram or a map, we always write them in the same order. The drawn length first, the length on paper, and the actual length second. So in this case, 1 centimeter on paper represents 20 meters in the real world. We can write this as a ratio. 1 centimeter represents 20 meters. To write this as a more usable ratio, we can convert them both to the same unit. So here I've got 1 centimeter is 20 meters. They're different units. Can we convert 20 meters into centimeters? 20 meters is 2,000 centimeters because 1 meter is 100 centimeters, times by 100. Now that these are both in the same unit, I don't even need the unit at all. A ratio usually doesn't need any units in the end because both quantities are in the same unit. 1 centimeter is on paper is 2,000 centimeters in the real world. When I say scale factor, I mean what 1 unit on paper represents. If I have the paper, how much bigger is the real world than the paper? In this case, the scale factor is 2,000 because the real world is 2,000 times the size as this diagram. Now I can investigate different lengths on this diagram. For example, I've marked here the length of Kurrajong, the reception to year 2. And we can look at, well, how long is Kurrajong along South Terrace? How many meters is it? Well, first we can measure it with a ruler. So you can grab your ruler out and measure it. The drawn length, the length on paper, is 4 centimeters here, if you measure it with your ruler. And so now I can figure out what the real length is in the real world. 1 centimeter on paper represents 20 meters in the real world. That comes from our ratio up here. And I've just measured this distance on paper to be 4 centimeters. So it's 4 centimeters on paper matches some unknown quantity in the real world. Do you notice that I've written just above this ratio here that the 1 centimeter is drawn on paper and the 20 meters is the actual length in the real world? It just makes it easier to remember which is which one's on paper and which one's the real length. So now I've got a proportion problem, and you can go back to my video on proportions to learn how to solve that. But basically we need to think, how do I get from this number, 1 centimeter, to this number, 4 centimeters? I multiply by 4. So 1 centimeter times 4 is 4 centimeters. That checks out. So 20 meters times 4 is 80 meters. And remember, of course, we need a unit. So Kurrajong is 80 meters long. Similarly, we can do the reverse problem. If we know the real world length, in this case the real world length of the new middle school building, now called the Graham Lang Centre, is 50 meters long, we can figure out how long we need to draw it on the diagram. And again, I can start with the scale that's given in the question, that's given in the diagram. 1 centimeter is to 20 meters. And that scale, 1 centimeter drawn on paper, is 20 meters in the real world, actual. In this scenario, am I told, I've got this information here, the middle school building is 50 meters long. Is that drawn or is that actual? That's the actual length. The actual length is 50 meters, so I can write that here. All right, well now I can do the same thing as before to solve this proportion. To get from 20 to 50, 50 is bigger than 20, so I need to multiply by something. I need to multiply by 2.5. If you're not sure how I got this number, try putting 50 divided by 20 in your calculator. If you're not sure, you can always check as well. 20 times 2.5, put that in your calculator, and yes, that really does equal 50, so we got the right number here. All right, well now we can figure out what this square is. The square is 1.5 times 2.5, sorry, 1 times 2.5, which is 2.5. So the drawn length, the length that I need to draw this in my diagram, is 2.5 centimeters. Let's imagine that you don't have a scale diagram yet, and you want to draw one on paper, a scale diagram of your house, for example. I did this when I wanted to make a Christmas decoration of my new house as a little tiny scale model of the house for the Christmas tree. So imagine we're drawing a scale diagram on paper, and the scale is 1 to 40. How long should we draw these different objects? So if the real world is 40 centimeters, that will be represented on paper by 1 centimeter. The scale factor is 40. The real world is 40 times as big as the paper. Knowing that, if you want to get from the real life length to the length on paper, you can just divide by 40. A real life length of 80 centimeters, if I divide that by 40, gives me 2 centimeters. Similarly, a real life length of 2 meters, to draw that on my little piece of paper that probably won't be measured in meters, that's really big for a little piece of paper. We'll first write 2 meters divided by 40, but let's convert this meters into centimeters. 2 meters, how many centimeters is that? That would be 200 centimeters. So I can replace 2 meters with 200 centimeters. Those things are the same, so this equation is true. And now 200 centimeters divided by 40 is 5 centimeters. Now here I told you what the scale should be, but if you're making your own scale diagram from scratch, you won't know what that is. You'll need a way to figure out a good scale. So I'll show you one strategy to figure out what a good scale should be. We can use trial and error to find a sensible scale. In this case, I've got a Boeing 767. It's 61 meters long. What would be an appropriate scale to draw that? Well, 61 meters, I'm going to rewrite in centimeters because when I draw my little scale model, it will probably be on a little piece of paper in centimeters. Let's try dividing it by 10. That will give me 610 centimeters. Is that a reasonable size to draw in my maths exercise book? Not really, that's 6 meters long. So let's try a scale factor of 100. If I do this divide by 100, will that fit? 61 centimeters still won't fit in a single A4 page. An A4 page is about 30 centimeters long. Alright, well what if I try dividing by 1,000? That's 6.1 centimeters. Is that a good size? I think that's a good size to draw in your exercise book. If you went even smaller, well then it might be too small. You won't be able to make out the detail. So a suitable scale is 1 to 1,000 because the scale factor is 1,000. I hope this has been helpful. Good luck. Ask me questions. See you everyone. Bye.